This is the T3 fuel injector side pipe disassembly station project, sponsored by Bosch Fuel Systems. The purpose of this project is to design a station to disassemble a Tier 3 fuel injector side pipe in order to remanufacture existing parts that have returned from their use in locomotive engines. Remanufacture results in high-quality parts at lower overall cost. 4 components are to be reclaimed for remanufacture by this disassembly station. They are the outer sleeve, high-pressure shaft, T-piece, and left-hand nut. 2 O-rings and a ball and spring will be scrapped after disassembly. This design must assist all critical disassembly steps, maintain all applicable Bosch safety standards, and be able to continue disassembly of a side pipe in any condition that it would come from the field. After careful research, the selected design for the disassembly station was to use a manual fixture to remove the O-rings, an electric impact driver for left-hand nut removal, a pneumatic cylinder to remove the outer sleeve, and an electric motor to separate the T-piece and high-pressure shaft. This design was chosen for its simplification of operator actions, the minimal physical force requirements from the operator, and its overall cost. Touch safety controls will be utilized for operator safety. The overall layout of the design stations are shown here. The left green area is where the left-hand nut and outer sleeve is removed. The center blue area is where the tool for removing the O-rings is mounted, and the rightmost area is where the T-piece and high-pressure shaft are separated. Here's a close-up of the outer sleeve removal station. Once secured in the fixture with the left-hand nut removed, a pneumatic cylinder will pull the outer sleeve off using a sheet metal tool. This is a close-up of the linear slide and hex socket assembly used in separating the T-piece and high-pressure shaft. The linear slide and the hex socket allow for easy maneuvering of the side pipe and hold the side pipe in place while the T-piece is removed using an electric motor. Various design challenges were experienced. FEA analysis was performed to ensure that the hex socket and sheet metal tools could withstand the forces applied to them. The minimum size and fatigue effects on bolts used in T-piece removal were calculated to ensure that the repeated impacts could be withstood. The results of the project were that the specifications were met for the disassembly station, and the design was approved by Bosch for future implementation. Due to current circumstances, the originally planned build of the station could not be performed. In place of this, additional consulting was done for further process improvement.